Good morning, everyone. My name is Reagan Sokolowski, and I'm a marketing specialist here at ESC Spectrum. Today, I'm here with Software Engineer 3, Andrew Hatcher, who will be giving us an overview of the latest features and updates to our RATAView software. Without further ado, take it away, Andrew.
All right, thank you, Reagan. My name's Andrew Hatcher. I'm a software engineer here at ESC Spectrum, and today we're going to be talking about RATAView. I'm just going to do a brief overview of RATAView, and then we're going to get into a demo of the product. So, as the name suggests, it's software for stack testers. So, kind of a background of RATAView. One of our customers contacted us and asked if we could develop testing software for them. We also have an in-house testing department, and they were using some older software that was probably written back in the 90s. So it's a little outdated, and kind of needed a replacement for that since it didn't support newer hardware. And we kind of worked with our in-house testing department to develop this software. We wanted the software to do kind of the following 6 things. Control the I/O. It needs to be able to turn on digital outputs to turn solenoids on and off. Obviously collect data, kind of guide the user through the process of performing a RATA. It needs to store results, perform calculations, and report that results. This software is written specifically for testing. It's not just some generic software that was as testing kind of thrown in as an add-on. Kind of makes for an easier to use product with less errors and downtime. A little bit about RATAView. Obviously, it helps stack testers perform relative accuracy test audits. As I mentioned earlier, our in-house stack testers helped develop the product. It's a subscription-based product that comes packaged with an 8864 data controller. I believe it's a yearly subscription. It allows for faster testing and reporting using test templates and customizable reports. As with all of ESC Spectrum's software, it's backed by a 24/7 customer support team. And this is built on our SpectraView Prism DOS platform, so it is actively developed. So what is RATAView? Well, it consists of a Windows server and a 8864 data logger. It uses our Prism DOS services, which again are actively developed. It has a SQL Server Express database. There's a RATAView Windows client application, which we'll be demoing later, and that can run on the server itself or on a laptop that connects to the server. And we have Excel spreadsheets that pull in data from RATAView and allow you to report the results of the test. So what does it do? Well, it simplifies regulatory compliance by allowing you to automate a test, and it helps troubleshoot and resolve problems. We have a page on the software itself that will allow you to view I/O, so you can toggle digital outputs on and off, make sure they're working. You can see analog scaling and also the current analog value. And it speeds up the reporting time by pulling in data for you, so you don't have to constantly hand enter values. The control flow is the I/O signals originate at the analyzers and devices. Those devices are hardwired to an 8864 data controller, or we could use a Modbus device, but again, most customers use 8864s. The RATAView server will communicate with the 8864 and collect 10-second averages. It also reads real-time data, and that controller also turns on digital outputs. The RATAView client communicates directly with the server, and the client can also be installed on the server if you want to do it that way. And all the data is stored to the SQL Server database, so you can retrieve that data at any time. The workflow of the client itself, there's a configuration page that allows you to configure gas bottles. Probably be doing that a lot. You can edit analyzers. Analyzers will be pre-configured by the engineer who configures the system, but you can edit certain aspects of it. And as I mentioned earlier, there's an IO points page that will allow you to view analog inputs, digital outputs, and do troubleshooting if you need to. You can build a test, which is simply a queue of steps. You can run the test in an automatic mode. Assuming everything passes, you just click run and let it go. You can pause the test at any time. It's largely automated though. While the test is running, you'll see real-time results. There is an automatic or a manual mode, and we have differing views. And all the reporting is done in Excel, and this Excel will pull in that data from the database itself, so you don't have to hand enter values. The advantages of RATAView, it allows you to configure a queue and then automate the test process, like I said earlier. Once you've done a test, you can then reuse that test at a later date and running it in automatic or manual mode. If something goes wrong, you can reset the test, clear out the results, and you can start over. And you can stop or pause the test as needed. It's designed to aid a knowledgeable user, so this is not really designed for someone who doesn't know what a RATA is. We're going to assume that if you're using this product, you know how to perform a RATA. That being said, there is a little bit of guidance. We do enforce the rules. That's about it for the advantages. For the design concerns, the biggest concern is making sure that the product is stable and reliable. A lot of these test trailers, you're not going to have internet access. So if something goes wrong, well, we don't want something to go wrong because we won't be able to log in to help you. You need to be able to stop the test, pause or resume it. You need to be able to reset a test, delete, add, remove runs, or QA. You may need to rerun a step. We obviously save the results to the database. As I said earlier, we have guided actions, but there are overrides that are available. Data can be retrieved at any time because it is stored in a SQL database. And we work with a range of IO devices, but again, most of you will probably be using an 8864. So for the spreadsheet itself, this is kind of a screenshot of one of the pages on the spreadsheet. You'll notice there's a test ID. RATAView will create a unique test ID for every test that you run, and you use that ID in the spreadsheet to tell it which test to look for. There's an auto update line here that allows you to turn on or off the spreadsheet's ability to automatically retrieve data from the database. If it's on, then the spreadsheet will poll the database every minute and retrieve data and fill it in. And these three green tabs down here at the bottom are the tabs that are used to pull data from the database. Every other tab in here is customizable. You can do whatever you want with it. If you don't like our template, you can make your own. That's totally fine. So like I said, we provide you with a pre-configured spreadsheet. These are a few of the screenshots. Again, if you don't like them, you can customize them make them do whatever you want, but these are the ones we use, and we will provide them to you with RATAView. They connect to the SQL database and they retrieve the data automatically. Test data is imported into the spreadsheets, and all the data on the spreadsheets are populated from those green tabs I mentioned earlier. They can be saved and archived and handed over to the customer. The reporting time is obviously going to be reduced because you're not hand entering everything. And as I said, they're included with a RATAView purchase. So how would you troubleshoot any problems with RATAView? You can view all the inputs on a single tab, and we'll be going over that when we do the demo. And you can change the scaling on the analog inputs very easily. You can easily identify any active inputs. You can toggle the digital outputs before you do a test, perhaps, just to make sure they're all working properly. Just to sort of help you troubleshoot anything before a problem arises. And finally, we have what did we do in version 1.1? Well, we added a section to the test page to display the digital I/O points. You'll see it down here at the bottom left. So all the digital outputs configured for the RATAView system are displayed there. Any active digitals will be displayed at the top. You can toggle them on and off. It's just handy to see which outputs are turning on while you're doing a test. We also added a CARB QA method. CARB stands for California Air Resources Board, and as the name implies, it's only done for testing in California. The instruments can be made to use this method by changing the QA method on the Instruments tab, and I'll note that the instrument span must be entered when using this method. So that's pretty much it for the overview. I guess now we can get into the demo of the product itself. And so this is the main page for RATAView. Any prior tests will appear in this main panel here. I want to mention that I'm doing this on a SIMS system because it's the only system I have here that's connected to an 8864 and has digital outputs that work. So there may be some minor differences between what you would see in a real test trailer and what you're going to see in the SIMS here. So we'll start with the configuration page. And the first page that comes up is the bottle manager. You'll most likely be adding bottles to the system frequently. We have an active bottle inventory and an inactive bottle inventory. The only difference between these is that inactive bottles are hidden from the bottle selection menu when creating a test. This does not mean that they're retired bottles. But if you wanted to move a bottle from active to inactive, you can just drag it and drop it. To add a bottle, you just click the add button and it'll have a wizard come up. You give it a description, vendor ID, you give it a serial number, expiration date, certification date is optional. Click next, and then just add the constituents for the bottle. So if we want to do a NOx bottle, NOx, let's say 100 ppm, and give it a balance nitrogen, then just click finish, and that will add the bottle to the system. I don't want to actually add this since it's our training system, but that's how you would do it. You can edit existing bottles. Just click on the bottle. Over here on the right hand side, you'll see the details for that bottle, and then you can click edit. And you can change the constituents by double clicking and just entering in the new value. If you have a barcode scanner, you can click the scan button and it'll bring this pop-up up. You scan the barcode, and once it's scanned, this window will close and it will populate this wizard with all the details for that bottle. All you would have to do is enter in the description. Our next tab here is calculations. These calculations are for display purposes only on the test running page. Again, this is not what you would see in a normal test trailer. You're not going to see flow or heat input, obviously. But this is in case you're doing a RATA that requires you to use NOx pounds per million BTU, or say NOx corrected to 15% O2. You could see a real-time value while you're running the test. So you would add a new calculation by going to add, and it'll bring up a wizard. Most of these will probably be configured by the engineer who sets up the system. It'll use a predefined set of formulas and constants, but we could give this a name. The reporting group, you're only going to have one reporting group, so it'll be pre-populated. Next, select a formula. Again, this is not the same list of formulas that you would see in a real test trailer. It'll be far less. We can select NOx rate, populate the engineering units and decimal precision, and then fill in the constituents for the formula. But I'm not going to actually create one. But you can select these formulas or calculations and see what goes into them. See the dependent tags, the details for the calculation. You probably won't be using this page very much. This is most likely going to be used by the person setting up your system. But next we have instruments. And here's a list of all the instruments configured for the system. And again, this is a SIM system, so you won't see dual range instruments, and you won't see stack flow or opacity, but it works for a demo. You can't add these. That'll be done by the engineer who sets it up, but you can edit certain aspects of it. Just click on whichever one you want to edit, and then click the edit button. You can change the name or the description. You change the gas type. The IO channel, this would be used for in case an analog input goes bad and you need to move it to another point. We would have a generic list of IO points here that you could reassign them to. You can change the span value. I will mention that the span value is only used for VOC instruments or instruments that use the CARB QA method. And you can change the QA method from EPA, which is the default, to CARB. And if for some reason you need to change this from a dilution to or extractive to a dilution, just check that and click OK. Finally, the raw points page. And this is where you would do most of your troubleshooting. In a real test trailer, you would only see one source over here, and it would be the 8864 most likely. You can see the device address in case you need to log into it. You'll see a list of analog inputs. If we scroll down, we'll see a list of digitals. And you can right click on these and toggle them on and off. If you need to change the scaling of an analog input, you can right click on it and edit point scaling. If you're using a Modbus device, you could also edit the scaling counts, but that's not necessary for an 8864. But if you wanted to change the scaling, just right click, edit scaling, and then change it here. So that's basically it for the configuration screen. Now we can set up a test. We'll just go back. And to do a new test, click on New Reference Method. There's a unit here, which will be pre-populated for you because you'll only have one unit. Select which instruments you want to use for the test. We'll just use NOx and CO2, and then give the test a name. And then click Start Test to begin creating your queue. And I'll also say, once you've actually created your first test, you'll see a new tab up here that says create from previous. So you could use that test as sort of a template when creating your new test instead of just going through the process of creating a new queue. But anyway, let's go with start test. So this is the test running page. Over here on the left-hand side, you see the test ID, which, as I mentioned earlier, is used for the spreadsheet to tell it which test to pull the data for. You have the real-time averages or real-time values, rather, for the instruments that you selected. And the calculations that I mentioned earlier, this is where they're used. So if you wanted to see NOx pounds per million BTU, you could add calculations. Just right-click on NOx high range and select whichever calculation you want to see. Just go NOx rate, click add, and now there's a real-time indication of NOx rate. The new feature, or one of the new features, the digital outputs. See active ones are at the top, and then a list of all of the others at the bottom, and you can right click and toggle them from here if you need to. We have a manual test mode and an automatic test mode. The test will start in manual mode. This was a request from one of our in-house stack testers. He likes to do his calibration errors in manual and then switch to automatic afterwards. So from here, you would just add, or you would start configuring your queue. So click the add button, and you can do a QA, which we've sort of bundled cal error, bias and drift, NOx, converter efficiency, and so on into a term called QA. So we're going to start with a QA. And the only ones you can do to begin with are a cal error or a converter efficiency. We're going to do a cal error. And I want to note that there's a post QA purge sequence and duration down here. This is in case you want to sort of do a blowback after the cal error is finished. It won't do it after the first step. It'll do it after the cal error is finished. I'm not going to do that, but if you wanted to, you would just select the sequence. We could say manual blowback and however long we wanted it to run for. Again, I'm not going to do that. So once you've selected the QA class, just click next, and then we'll select the bottle that we're going to use for step 1. We'll just do the 0 gas, and then select which set points we want to use. Click add, and the object type, you can either do sequences or tags. Sequences will be configured by the engineer who sets up the system, and that's what we're going to select here. Sequences are simply a predefined set of outputs to turn on and off. So we'll just click add, and then we'll select our duration. We'll just do 60 seconds for this demo, and go to next. And then we need to assign the QA types to the instruments. Each instrument selected for the test will appear on this page, and the value column displays the concentration of the gas in the selected bottle for the instrument. And the QA type is either going to be none, 0, mid, or high, unless you have a VOC instrument, in which case that will also have a low option. And once a QA type has been assigned to an instrument, it's removed as an option for subsequent steps. So we're going to, this bottle is a 0 bottle for the NOx and CO2, but we could just as easily say it's only used for NOx and not used for CO2 at all, in which case we would select none, but we're just going to do a 0 for both of them. Click finish, and now we've got step 1. And then we need to finish, let me go back. Since we've started a cal error, we can't do anything else. Run is grayed out. If we go to QA, we can't select anything other than cal error. You have to finish the cal error. So it's considered finish when every instrument has every required step configured. So we still need to add a mid and a high for the NOx and CO2. So we'll just go next, and we'll use CalGas 2. We'll select CalGas 2, change that to 60 seconds, and we'll say that this is the mid gas for both of them. And still we're not finished, so cal error is the only thing we can do. And we'll use CalGas 5. Change that to 60 seconds. And we'll say that this is the high level gas. And you'll notice that low and mid are no longer options because they've already been used. So now our cal error is finished. We can add a run, or we can add a QA. Since these are set up as extractive instruments, we would need to follow the cal error up with a bias drift. And you don't have to go through the entire process for setting up a bias and drift that you did for the cal error. Once the QA class has been selected, you'll notice a new option appears to select the cal error steps. These steps are pre-populated. We use the cal error steps as the sort of templates. So let's just say we want to do a 0 for the first step, and we go next. Now we don't select a bottle here because the bias and drift has to use the same bottle as the cal error, and so it's also going to use the same set points. We do show the set, let me rephrase that. It uses the same bottles and it uses the same Q8 types. So you could possibly need to change the set points here. If it's an extractive system, you're going to do the cal error as a system cal, but you would do bias and drifts as a direct cal. So you would need to change this. We can pretend that this is a system cal sequence. So you would remove this and add back a, pretend that this is a direct cal sequence. So that's what you would do. And can finish. And then we've got our first step for the bias and drift. And since we're not finished with the bias and drift, we can't create a run, and we can't do anything other than finish the bias and drift. Step 1 is removed, so we either need to select a mid or a high. Let's do a mid. And then you could change this from a system to direct cal. Click finish. And we can add a run. The default is 21 minutes, but we're just going to change this to 2 minutes for the demo. And there's an option for a stratification. Really, the only thing this is here for is to it saves it as a different name so that the spreadsheet can differentiate between a stratification and a normal run. This is going to be a normal run though, so we're just going to say 2 minutes and add. And there's a response button down here. So you can start the test and do a cal error and bias and drift, but the run will not start until you've entered in a response time. And you do that by clicking this button, and note that this is in seconds. We're just going to do 1 second just to make this quick. Since it's less than 60 seconds, we're going to get a warning pop up just in case somebody is trying to blow through this and doesn't read that it's in seconds and thinks that they're entering it in minutes. So it's less than 60 seconds. Do you want to proceed? Yes, we do. So from here, we can just start the test if we wanted to. Obviously, there's more to a RATA than 1 cal error, 1 bias and drift, and 1 run. So I believe it's a minimum of 9 runs that you have to do. And I don't think anyone wants to go through the process of manually adding these bias and drifts and runs every time. So you can right click on this and duplicate QA and runs and tell it how many you want to create. We'll just do 8 and click OK. And that will take the last run and the last bias and drift that you've configured and duplicate them. So it'll do bias and drift, run, and so on. And that option is only available once you've configured one bias and drift and one run. There's an option to delete all non-performed QA steps and runs. I'm not going to do that because it'll delete everything because we haven't started anything. You can view or edit step actions. So if I were to view the step actions for step 2 here, it uses the manual CalGas 2 sequence. It has a duration of 60 seconds. As long as you haven't started the step, you can change this, but once the step is started, you can only view it. There's an option to change the bottle. This is only available if you right-click on a cal error step. 0 is the bottle we use, so can't change that. We'll just leave that at 0. If you don't like the order that you've set this up in, say you want to do the mid first, you can right-click on that and move up. And now mid will go before 0. And likewise, you can move it down. And now the 0 is first. We have 2 different views. There's a queue view, which is the default. This is the order in which the steps will run. If you click this, it'll do a split view. It sort of splits up the QA and the runs. We have another view over here. This little arrow will take us to the 1-minute averages for the runs. Since we haven't done a run yet, this is blank, but once the runs start filling up, you'll see each individual minute here. And I guess we can start the test now. We'll start it in manual mode. But once we click the start button, on the right-hand side, you'll see the step duration. And the duration is 60 seconds. You can change this on the fly. You can just run it up and down. The elapsed time, and it'll give you an indication of whether this is going to pass or fail. And NOx is going to fail because it's below the minimum boundary, and CO2 is going to fail because it's looks like it's above the maximum boundary. The steps that are in progress will be highlighted blue. There is an accept values button here, which let's say this is running for 300 seconds. If you're pretending, we can pretend that it's passing and we don't want to waste CalGas. We could just accept values and stop the test or stop this run, immediately evaluate it, and then go on to the next if you're in automatic mode. There's also an option to abort it. Say a solenoid didn't click or whatever, and you need to restart it. You can just abort it. It will stop the sequence that it's running. It will just pretend that this never happened, basically. But we're just going to accept values. And it failed, so everything is red. It's not going to pass because I don't believe we have CalGas bottles hooked up. But we can just click resume and go on to the next step. Notice this turns blue. And it's the same process as before. You just let it go until it passes. You can run this up or down. We'll just accept values. And then because we're in manual mode, we need to manually click resume. And there we go. So let's accept the values again, and we'll move on to the bias and drift. Let's just put that in automatic mode and just do resume. And basically you just let it run. Now there's a pause button here. This pause button will, if it's a QA, it will finish the QA step, or actually it'll finish the QA and then pause it after the QA. So this will finish the bias and drift, but will not start the next run automatically if you click pause. This pause button is also available while a run is going on. and that will do, you'll have two options there. You'll have an option to pause the run itself and an option to pause the test. Pausing the run will pause the run in the middle, so it'll finish the minute that it's on and then allow you to resume the run at a later time. If you pause the test, it will finish the run and then will not start the next QA that follows it. So let's accept values here, and we'll just go straight on to the next bias and drift. And we'll just accept the values here as well. And then it'll go on to the run. Our 1 minute response time is up, so it'll start at the next, the top of the next minute, which is 10:38. You'll see an indication up here of when the next run will start, which will be in about 25 seconds or so. But yeah, assuming everything passes, you just put it in automatic mode and let it run. I suppose we could, you could reset this QA if it, now we can't, but so the run is in progress now. You have a run duration up at the right-hand side, the elapsed time, and the current average for each instrument. And here's the pause option. Pause run, we'll finish it, we'll pause the test after the run is complete. If I were to click pause test, it would pause it, I'm sorry, pause test will pause the test after the run is complete. Pause run will finish this current minute and then pause the run. We don't want to do that though. There is a stop button. This is similar to pause, but it is very different in that it will stop the run. You will not be able to resume it. It'll just go on to the next thing. So if you've got a 21-minute run and you stop it 10 minutes into it, that's it for that run. It's over. I'm just going to pause the test after this. But I think that's basically it for the demo. I guess there's also a done button here. Done will signal the end of the test, and any test that's marked done cannot be continued or resumed at a later date.
Also, if you're interested in implementing RATAView at your facility, please visit our website and then you can fill out a contact us form and we'll be able to get in contact with you. Oh, here we go. This is from Wade Bice. He said, did you say that a yearly subscription was required? How many are currently being used in the field? I assume you're planning to incorporate the new data fields required by the electronic reporting rule that will be required starting the first quarter of 2023. And does our software report NOx pounds per hour or just ppm and pounds per and then BTU?
Okay, for a subscription, I believe it is a yearly subscription. I think sales would be better able to answer that than I am, but my understanding is that yes, it's a yearly subscription. What were the other questions?
Are you planning to incorporate the new data fields required by electronic reporting rule that will be required starting in the first quarter of 2023?
I assume that's referring to the new JSON format instead of XML. Yes, we will be doing that. That's all done inside of the spreadsheet. There's a tab in there that will generate the emissions or the RATA XML file. Yes, we'll be updating that to report as a JSON format. And I believe you had some other question.
Does your software report NOx pounds per hour or just ppm and pounds per, I don't know what this stands for, but MMBTU?
Yeah. So RATAView itself just performs the test. The results are done inside of a spreadsheet. So there is a tab to do pounds per million BTU. There's a tab that you can do NOx corrected to 15% or O2 or SO2 pounds per million BTU, NOx pounds per hour, and so forth. So that's all done inside the spreadsheet. And again, you can customize that as much as you want to.
We have a couple other questions. Does SIMS data import real time from DAHS or entered each run?
Say that again.
Does SIMS data import real time from DAHS or is it entered each run?
That's the one thing you'll have to enter in manually. The reason for that is these test trailers really don't have internet access, so they're probably not going to have any way to connect to the DOS. And if you're a third-party company, I think it's probably very unlikely that you're going to be able to get on a customer's corporate network to connect to the DOS anyway. So yeah, you'll have to enter that in manually, but that's done on the spreadsheet.
And then we have another. If you stop a run, do you delete it out or start a new one? Or delete it out and start a new one?
If you stop a run,
Yes.
I guess it depends on what your intent is. If I think that's mostly there for stratifications. One of our customers requested that. I think he set up like I don't know, an hour-long strat and wanted to stop it before it got to 60 minutes. So he wanted a stop button in order to stop the run, essentially. But if you stop it at say 10 minutes when you really need to do 21, then you would need to rerun the test, or you need to rerun that run. Because if you tried to do it again, it would only do 10 minutes. I hope that answers the question.
All right. Well, I think that's all the questions we have. If you have any more, you can feel free to email Andrew at ahatcher@escspectrum.com. Oh, we have one more. Does the software calculate converter CK for you?
Calculate what now?
The calculate converter CK for you.
I'm assuming they're referring to the NOx converter efficiency. Yes, there is an option to do that. I just didn't do it for this test, but yeah, that is there.
All righty. But yeah, like I was saying, feel free to email Andrew with any more questions. And like I said, if you're interested in RATAView, please just contact us on our website and we'll reach out to you. But thank you for today, Andrew. I appreciate your time and thank you, everybody.
Thank you.